Hello there. I'm going to try this with the mask on just because I probably should be safer about this. So let's go ahead and start with lesson 1-3, which is on evaluating limits analytically. Okay, so as long as you can hear me okay, then we are good to go. So, all right, let me clear this out real quick because I know I'll need it later. All right, now 1-3, you can read all the important information. Now, when we talk about analytically, let's first make sure the idea what the word analytic means. And basically, here's what it means. And let me get this set up here while we do that. Is that when we talk about analytic, it means we are using known rules, properties, and theorems to determine our response. We are not using graphs directly. We are not guessing. So that's the key thing to remember. There are a number of theorems we will be able to utilize to determine the limits of the more complex polynomials as long as they are what's called well-behaved. And we'll get into more detail on that as we go along. So in that case, we'll be using direct substitution as our main method. Okay, so there you go. You see this, and I'll post all this information afterwards. All right. Now, so basically, if the limit of 4 as x approaches -2, what's the limit of that going to be? Well, it's going to be simply 4. I know, sounds like a no-brainer. Well, guess what? It's pretty much what it is. Okay, so if the limit of x as x approaches c is c, then the limit of x as x approaches 3 is going to be 3. And the same thing here with this one. The limit of x of n as, if the limit of x of n equals c of n as x approaches c, then that means the limit of x squared as x approaches 5 is going to be 5 squared, which you can figure out that to be 25. Okay, those are just some practice problems, just kind of things to get you back into the swing of things. All right, now, here's some more properties of limits. Okay, you can kind of read through those. Scalar means if you multiply limit of b times f of x as x approaches c is going to be b times L. That's, of course, now remember, this is as long as the limit of f of x as x approaches c is going to be L. And also the limit of g of x equals k as x approaches c. Little thing I should throw in there real quick. All right. It says the sum of the difference of the two functions, the limit of the sum of the difference of two functions is going to be the limits. Same thing with the product, same thing with the quotient, and also the same thing with the power. So all of those right there. So I'll let you look over those for a moment. And now let's apply them to these examples right here. First of all, determine each of the following limits as x approaches -3 is going to be 2 times, excuse me, I wrote the wrong term. Let me fix that. I'm still kind of learning this, and I'm also making fun of myself as I do that. -3 squared minus 5, which when you figure that out is going to be 13. All right. And then the same thing down here. When we plug this in, square root of 3 plus 6 all over 3 plus 3, that is going to be 3 over 6, which is 1/2. All right, so we got that. Now, let's apply what we have here. Okay, so we know that the limit of f of x as x approaches c is going to be 5. So if I multiply that by, if I take the limit of -3 times f of x as x approaches c, that's going to be -3 times 5, which is simply -15. And the same thing goes here. The limit of g of x is -1. So I got -1 minus f of x, which is 5, which is simply -6. But the limit of the product is just simply going to be 5 times -1, which is going to be -5. And then if I do the same thing for the exponent, it's going to be -1 cubed, which is -1. And then finally, the last one is going to be 5 over -1, which is simply -5. All right. Those are basically plug in and stuff you've seen. It's like kind of like a lot of this is algebra. Now I will tell you this. This is something Mr. Taylor used to tell me when I was in his calculus class a long time ago. Actually, it was 30 years ago. All right, we're back into it. I had to check on something real quick. So here we go. All right. Now, the same thing goes with radicals. All you have to do is just simply plug everything in. And here our example is down here. If I simplify this, determine the limit of the cube root of 2x squared minus 10 as x approaches 3. Just simply plug it in. It's going to be the cube root of 2 times 3 squared minus 10, which when you simplify all that is going to give you a value of the cube root of 8, which is 2. All right. Just a little bit of algebra there for you. So now, as I stated a moment ago, a lot of this is algebra. Calculus is based on algebra. It's also based on geometry and all the other classes, but it's mostly algebra. All right. Now, how to handle limits when direct substitution fails. We talked about this a little bit last time, but I'm going to go over this again with you. So, basically, can we use direct substitution to determine the result? Is called intermediate form. In other words, we have to do further analysis to determine the limit. So, if we look at that, if the functions that agree at all but one point, let c be a real number and let f of x equal g of x for all x not equal to c in an open interval. If the limit g of x as x approaches c exists, then the limit of f of x also exists, and the two limits are equal. So here's what this means. All right. So what this means is this, and we talked about this a little bit in 1-2, but I'm going to give you a better example of this right now. If we were to plug in this number, it's going to be -2 plus 2 over -2 squared minus 4, which is going to give us 0 over 0. Okay. All right. We can't do that. But if we simplify this, we can. So here's what we can do. It's telling us that long theorem there, the long theorem 1/7 that I just read to you means this. If I take x plus 2 over x plus 2, x minus 2, those two are canceled, and that's going to be 1 over x minus 2. So it's saying that this limit right here equals the limit of this as x approaches -2, which is going to be 1 over -2. Let me erase that. Which is 1 over -4, 1/4. So it's saying this limit equals the limit of this as long as x is approaching -2. So both this limit and the limit of this are both equal. So when we solve it, we get -1/4. That's what it's saying. It's a complicated way of saying all that. All right. So, and the same thing goes for this one right here. So if I simplify that, it's going to be x cubed minus 1. So the limit of this is going to equal the limit of x squared plus x plus 1 times x minus 1 Now, this equals that. I learned that from looking at an old Algebra 2 book. That's how I know that. I didn't memorize it. If you knew that going in, congratulations, because I didn't. I looked it up. And a lot of what you're going to be doing is looking up as well. So these two cancel. Now I'm left with x squared plus x plus 1. And if I take the limit of that as x approaches 1, I get 1 squared plus 1 plus 1, which is 3. 3. All right, now, I am going to pause this right now, and I'm going to stop this video because I'm going to run out of time here in just a couple minutes. So, and then once I'm done, we'll go over part 2.